Number 1. The Ghost Hominin, phantom population in West African DNA. The first horror in this investigation has no skeleton. It has no cave. It has no tool. It has no skull. It exists only as a shadow inside the cells of living people walking the streets of Lagos, Banjul, and Freetown today. To understand this shadow, we have to abandon the simple textbook idea of Africa as a single birthplace of modern humans. The continent was not a tidy nursery. It was a vast network of overlapping populations, separated by deserts, rainforests, and tens of thousands of years, sometimes meeting and mixing, sometimes drifting apart for hundreds of millennia. Somewhere inside that ancient network, a population existed that we have never seen, and that population left a fingerprint we can still read. Geneticists call it a ghost population, a lineage inferred entirely from statistical patterns in DNA before any fossil has been identified. The technical clue is unusually divergent haplotypes, meaning long stretches of genetic code that look far older than the rest of the genome. These haplotypes appear at elevated frequencies in West African groups, particularly in Yoruba, Isan, Mende, and Gambian-related samples studied by major genome projects. In 2018 and 2020, models published by Sriram Sankaraman and Arun Durvasula at the University of California, Los Angeles, suggested that roughly 7 to 19% of the ancestry of certain West African populations may come from an archaic source that split from the modern human lineage more than 600,000 years ago. Translate that into a modern frame. That is older than the entire history of our species, longer ago than the first known Homo sapiens fossils from Jebel Irhoud in Morocco. The mechanism is called introgression. Two long-separated populations met, interbred, and produced descendants whose DNA quietly carried fragments of both lineages forward. The bodies of the archaic group eventually disappeared. Their genes did not. This is essentially the same process documented for Neanderthals and Denisovans in Eurasia, but with one critical difference. Neanderthals have hundreds of skeletons. Denisovans have a finger bone, jaw fragments, teeth, and a skull cap. The West African ghost has nothing. Not a single jaw, femur, tooth row, cranium, hearth, or stone industry has been confidently linked to it. There's a reason fossils are scarce. West and Central Africa are some of the most hostile fossil zones on the planet. Acidic rainforest soils dissolve bone within a few thousand years. Humidity destroys collagen, which is required for ancient DNA recovery. Dense vegetation buries surfaces. Erosion shuffles deposits. Ancient DNA from these regions is almost non-existent compared to the cold, dry caves of Eurasia. In 2023, a competing model from researchers including Aaron Ragsdale and Brenna Henn proposed that the same genetic signal might not require a separate archaic species at all. Instead, it could come from a weakly structured stem population inside early Homo sapiens itself, a network of interlinked African groups that exchange genes intermittently across enormous distances and time spans. That is the mainstream interpretation today. The historical archaeology lane suggests the signal could represent an unsampled Middle Pleistocene African hominin population, perhaps related to Homo heidelbergensis-like Africans, or to the lineage that produced Homo naledi-level surprises. The fringe-eyed lane proposes that multiple unknown human forms survived late on the continent and mixed repeatedly with our ancestors before vanishing entirely. What we can say with confidence is narrow. Hundreds of millions of people alive right now may carry DNA traces from a population that archaeology cannot yet see. The bones may exist. They may be sitting in a museum drawer, misidentified. They may be dissolved in the soil of a Cameroonian forest. We do not know what these people looked like, where they lived, or why nothing recognizable has survived. So if their genes are still here, why has not one bone been recognized? Hold that question, because the next case has the opposite problem. There are bones. There may even be tools. What is missing is the body of a suspect. Number 2. The Cerutti Mastodon site. San Diego, around 130,000 years before present. In the early 1990s, a freeway construction project in San Diego County exposed a buried Pleistocene deposit. Inside that deposit, paleontologist Richard Cerutti and his team from the San Diego Natural History Museum recovered the remains of a single mastodon. Mastodon bones in California are not by themselves unusual. What was found alongside the bones is what makes this the most controversial archaeological site in the Americas. Mastodon teeth, tusk fragments, broken ribs, broken limb bones, and large rounded cobbles were arranged in a pattern that, according to the original investigators, looked deliberate. The date is what makes the site explosive. Uranium series dating placed the bones at approximately 130,700 years old, plus or minus 9,400 years. Place that in modern context. Mainstream models place the widespread human settlement of the Americas somewhere between 16,000 and 25,000 years ago. Cerutti is more than 100,000 years earlier than that. The evidence cluster includes spiral fractures, which are curved breaks that occur when bone is struck while still fresh and elastic, and percussion damage in the form of impact notches and detached bone flakes. Several large cobbles in the deposit show wear and microscopic damage interpreted by the original team as hammerstone and anvil use. To test the interpretation, the team performed experimental replication. They struck modern elephant bones with stone hammers and anvils and compared the resulting fracture patterns to the Cerutti material. The patterns were similar enough that in 2017, the journal Nature published a paper by Stephen Holin, Thomas Demarais, Daniel Fisher, Richard Fulligar, and colleagues formally proposing the site as evidence of human or hominin activity at 130,000 years ago. A 2020 follow-up reported microscopic bone residues on the cobbles, interpreted as further support for hammer and anvil use. The mainstream skeptical response is that natural forces can explain everything. The bones could have been broken by sediment compaction, trampling by other megafauna, or even the heavy machinery used during freeway construction. There are no clear-cut marks from sharpened stone flakes, there is no hearth, there is no camp, there are no human bones. The archaeological and historical lane is more cautious. It suggests that an unknown early hominin group, perhaps related to populations leaving Asia, may have reached North America far earlier than the standard timeline allows. The fringed lane goes further, proposing that pre-Homo sapiens humans, possibly Denisovan-related or representing some other Eurasian lineage, briefly entered the Americas and vanished without leaving any descendants. The case is weak by traditional archaeological standards because it lacks diagnostic stone tools. It is strong enough to keep generating papers because the breakage pattern, the stone association, and the date are difficult to dismiss casually. The entire interpretation hinges on taphonomy, which is the science of what happens to remains after death. Was the bone breakage cultural, or was it accidental? If it was butchery, no continuous population followed. There is no later tradition, there is no migration trail leading anywhere. Compare Cerutti with sites like Monteverde in Chile, which pushed back the human arrival in the Americas to roughly 14,500 years ago and is now broadly accepted. Even the most aggressive pre-Clovis sites are nowhere near 130,000 years old. Cerutti stands alone. Is it impossible archaeology, or is it a paleontological accident that happens to look disturbingly human? Bones break for many reasons, stones cluster for many reasons. The next case has neither bones nor stones at the center. It has bodies, perfectly preserved, dressed in patterns that should not exist where they were found. Number 3. The Tarim Basin Mummies, Taklamakan Desert. The Tarim Basin sits in the Xinjiang Uyghur Autonomous Region of northwestern China. It is bordered by the Tian Shan, the Pamirs, and the Kunlun Mountains, and at its center lies the Taklamakan Desert, one of the driest and most isolating landscapes in Inner Asia. Beginning in the early 20th century and accelerating with later Chinese excavations at sites like Xiaohe and Gumugu, archaeologists recovered hundreds of naturally mummified human bodies dating to roughly 2100 to 1700 before Common Era, which places them in the early Bronze Age. Preservation here is the result of physics, not embalming. The desert provides extreme aridity, the soils are salt-rich, the graves were sealed with cattle hides, and tightly fitted boat-shaped coffins. Together, these conditions arrested decay. Hair, skin, eyelashes, fingernails, woven textiles, and grave goods survived for almost 4,000 years. The public image is striking. Many of the mummies have light brown, red, or blonde hair. Their faces are sharply featured. They wear felted and woven wool garments, sometimes plaid-like in pattern, with sturdy leather boots and pointed felt hats. For decades, the assumption was that these people were migrants. Two main candidates dominated the literature. The first was the Afanasyevo culture, a Bronze Age group from the Eurasian steppe with documented westward and eastward expansions. The second was the Bactria Margiana archaeological complex, known as B-Mysi, an oasis farming civilization centered in present-day Turkmenistan and Uzbekistan. Both groups had the technologies that the Tarim mummies clearly possessed. Both were geographically plausible. In 2021, the journal Nature published a genomic study led by Christina Wariner, Chungwen Jeong, Yinkyu Kui, and colleagues. They sequenced 13 of the earliest Tarim Basin individuals and 5 from the nearby Dzungarian Basin to the north. The result overturned the migration assumption. The Dzungarian individuals fit an Afanasyevo-related profile. The Tarim individuals did not. They did not match BMAC ancestry either. Instead, the Tarim Basin people carried ancestry deeply related to the ancient North Eurasians, a hunter-gatherer lineage from the late Pleistocene that elsewhere in Eurasia mixed with later populations and largely disappeared as a distinct group. The Tarim mummies were a genetic relic, an isolated remnant of a much older Eurasian world. The contradiction is the heart of this section. Their material culture was cosmopolitan, their ancestry was not. Dental calculus from Shaohe individuals contained milk proteins, indicating that dairy pastoralism was practiced from the foundation of the site. Their broader subsistence package included cattle, sheep, and goats, wheat, barley, and millet, all of which were domesticated elsewhere and arrived in the Tarim Basin through cultural transmission. They wove twill textiles. They built distinctive coffins. They left behind a pastoral economy that would have been familiar from the steppe to the Iranian plateau, but their genes show no significant input from those regions during the early period. The mainstream theory is that a genetically isolated local population adopted technologies, crops, and pastoral practices through cultural contact rather than through demographic replacement. The historical theory frames the Tarim communities as nodes in a Bronze Age exchange network, an early version of what would later become the Silk Road, where ideas moved farther than people. The fringe lane suggests the mummies represent a lost remnant population whose culture traveled outward but whose genes never refreshed. A note on a popular claim. The plaid-patterned textiles are real and have been studied closely by Elizabeth Wayland Barber, but they are not Scottish clan tartans. They are an early example of twill weaving with multiple colored yarns, which is a technique that arose in several places. As for the Tocharian languages, those are an Indo-European branch that appears in the Tarim Basin centuries later in written records, and there is no firm proof that the earliest mummies spoke them. What was lost is everything that does not fossilize. Their language, their kinship structures, their songs, the meaning of the patterns in their cloth. How does an isolated desert population absorb so much outside culture without becoming genetically absorbed itself? Hold that, because the next horror has nothing to do with people at all. It is older than humans by tens of millions of years. Number 4. Libyan desert glass, a 29-million-year-old desert catastrophe. In the Great Sand Sea of western Egypt near the Libyan border, the desert floor is scattered with pieces of pale yellow-green glass. The pieces range from pebble size to chunks weighing several kilograms. The reported strewn field covers approximately 6,500 square kilometers, an area roughly the size of the United States state of Delaware. The age of the material is approximately 29 million years. There were no humans then. The earliest hominins would not appear for another 23 million years. The glass itself is unusual. It is extremely silica-rich, sometimes exceeding 98% silicon dioxide, which is purer than most industrial glass. It ranges from translucent to opaque, with colors that include yellow, greenish-yellow, and whitish tones. It also contains Le Chatelierite, a high-temperature silica glass that forms only when silica is heated above about 1700 degrees Celsius, which is far beyond what wildfires or normal surface processes can produce. The cultural afterlife of this material is what makes it linger in human memory. Roughly 3,300 years ago, ancient Egyptian artisans found pieces of this glass scattered in the desert and carved one into a scarab. That scarab was set into a pectoral ornament that was buried with the pharaoh Tutankhamun and rediscovered in 1922. The Egyptians did not know that they were wearing the residue of a cataclysm, older than the Atlantic Ocean as we know it. The technical problem is straightforward. To melt silica-rich desert material on this scale, you need extreme heat. To produce Le Chatelierite, you also need high pressure or extreme local temperatures. Two main models compete to explain how the heat was delivered. The first is a meteorite impact, which would produce shock waves, melt sheets in a crater. The second is a low-altitude airburst, in which a meteor explodes in the atmosphere and radiates heat downward without a hard ground impact, which is similar in mechanism to the Tunguska event in Siberia in 1908, though far larger. Recent work has strengthened the impact interpretation. In 2019, researchers led by Aaron Cavosi at Curtin University in Australia identified rhyodite-related signatures in zircon grains within the glass. Rhyodite is a high-pressure form of zircon that forms only at pressures associated with major impacts. That is difficult to explain with an airburst alone. The mainstream theory now favors a meteorite impact that produced high-pressure shock and melted silica-rich surface material. The historical theory adds a human dimension. Ancient Egyptians later found the glass, valued it, and incorporated it into royal symbolism without any knowledge of its origin. The Fringe-Lane proposes a low-angle cosmic fireball or a hybrid airburst and impact event that melted the desert without leaving a recognizable crater. The missing crater is the central problem. Several candidates have been proposed, including features in the western Egyptian desert, but none have been confirmed as the source. Possible explanations include burial under shifting Saharan sand, deep erosion over 29 million years, a low-angle impact geometry that distributed energy laterally, or an offshore structure now hidden beneath sediments. Modern relevance is significant. Libyan desert glass helps planetary scientists study impact hazards, airburst dynamics, and how cosmic events alter planetary surfaces. It is essentially a natural laboratory for events that, if repeated today over a populated area, would be catastrophic. What kind of event melts a desert, leaves royal jewelry behind tens of millions of years later, and hides the crater forever? The next mystery is also about endurance, but instead of a single moment, it is a pattern that lasts for 1.5 million years. Number 5, the Acheulean Stasis, 1.5 million years of one-tool form. The Acheulean is the longest-running technology in the human story. The earliest Acheulean hand axes appear in the archaeological record by at least 1.76 million years ago at the site of Kokosile 4 in West Turkana, Kenya, dated by Christopher Lepre and colleagues. Some later Acheulean traditions persisted into the Middle Pleistocene as recently as about 130,000 years ago in parts of Africa and Eurasia. To translate that into a modern frame, the entire history of Homo sapiens, perhaps 300,000 years, fits into the tail end of the Acheulean. The object itself is a bifacial stone tool, meaning it is flaked on both sides. The most iconic form is teardrop-shaped, but the family includes ovatiforms, pointed forms, and broadly symmetrical cleavers. The geographic spread covers Africa, the Middle East, South Asia, and parts of Europe, with isolated examples in Eastern Asia. The likely makers include Homo erectus, Homo ergaster, Homo heidelbergensis, and early Neanderthal-related populations. There is a learning curve worth noting before we discuss the stasis. The Acheulean did not appear from nothing. It was preceded by the Oldowan industry, which goes back at least 2.6 million years to sites in Ethiopia like Gona. Oldowan tools are simpler. They are typically cores with a few flakes struck off to produce sharp edges. The transition from Oldowan to Acheulean involved a major cognitive jump. Acheulean toolmakers had to mentally template a finished form before striking the stone. They had to manage platform preparation, edge thinning, and bilateral symmetry across both faces. Experimental replication studies, including work by Dietrich Stout at Emory University, suggest that producing a competent hand axe requires hundreds of hours of practice and possibly some form of demonstration-based teaching. The horror is what happened after that jump. For more than 1 million years, that broad solution did not change in any fundamental way. There was variation, sizes differed, raw materials differed, regional styles existed. But the core idea of a symmetrical bifacial hand axe was repeated across continents and across at least 4 different hominin species. Compare this to the modern human record. In the past 40,000 years alone, our tools have moved from blade industries to atlatls to bows, agriculture, metallurgy, the printing press, electricity, and computing. The mainstream theory is that the hand axe was simply too good to replace. It worked as a butchery tool, a woodworking edge, a hide processor, a digging implement, and a portable source of sharp flakes. The historical theory proposes conservative teaching traditions. Knowledge was transmitted carefully, generation after generation, with little incentive to deviate. The fringe theory, advanced in different forms by researchers including Thomas Wynne and Frederick Coolidge, suggests that Acheulean makers were intelligent in many ways but lacked what is now called cumulative culture, the process by which improvements build on previous improvements rather than resetting each generation. There's also a strong preservation bias to acknowledge. Wooden spears, fiber containers, digging sticks, hide clothing, and any kind of perishable craft would have decayed in nearly all cases. The Schöningen spears in Germany, dated to roughly 300,000 years ago, are one of the rare exceptions and hint at sophisticated wooden technology. It is possible that Acheulean people had a far richer technological world than the surviving stones suggest, and that we are only seeing the durable fraction. So was the hand axe a cognitive ceiling, a perfect design, or the only surviving trace of a much richer lost technology? The next case shifts from objects to landscapes, from a tool repeated 500,000 times to a single landform repeated 500,000 times. Number 6. The Carolina Bays. 500,000 elliptical scars. Across the Atlantic coastal plain of the United States, from southern New Jersey through Maryland, Virginia, the Carolinas, Georgia, and into Florida, the landscape is dotted with shallow elliptical depressions. They are called Carolina Bays, although regional names vary, including Delmarva Bays for the variants on the Delaware, Maryland, Virginia peninsula. Estimates of their total number commonly cite around 500,000 features. Some are small, only a few hundred meters across. Others span several kilometers. They are mostly shallow basins, often with a sandy rim on the southeastern side, and they typically host wetland communities, pocaceans, ponds, or seasonally flooded meadows. The strangeness comes from the alignment. Across very large regions, many bays share a similar long axis orientation, although the orientation shifts geographically. From the air, especially under modern light detection and ranging surveys, often called LiDAR, the bays appear as a vast field of consistent ellipses, sometimes overlapping and superimposed on each other. Dating the bays is genuinely difficult. The basin floor sediments may record one age. The sandy rim may record another. Peat layers inside the basin may record a third. Reworked sediment may record a fourth. A single bay can form, partially fill, erode, reactivate during a wetter climate phase, and be modified again during a drier one. Different studies using optically stimulated luminescence and radiocarbon have produced ages ranging from a few thousand years to more than 100,000 years. The bays were not all made at once. The mainstream theory, supported by geomorphologists including Andrew Avester at the University of West Georgia and others, is that wind, wave action, lacustrine processes, and Aeolian reworking shaped the basins over multiple climate cycles during the Pleistocene. Prevailing winds during glacial periods pushed water inside shallow ponds, eroding the southeastern shorelines and depositing sand on the rims. The historical Lane notes that indigenous peoples of the southeastern United States later incorporated these wetlands into their hunting, gathering, and ecological practices, but did not create them. The fringe theory is the most dramatic. It proposes that the bays were created by cosmic impact debris, perhaps a swarm of icy fragments from a comet that broke up in the atmosphere, or by ejecta from a single large impact further north on the Laurentide ice sheet. Some versions tie this to the Younger Dryas impact hypothesis, which is itself controversial. The reason this idea struggles with mainstream geologists is that the bays do not contain the diagnostic features of impacts. There are no shocked minerals, no shatter cones, no consistent meteorite fragments, and no true crater morphology. The reason it persists is that the alignment patterns and the sheer number of basins feel, intuitively, too organized for slow natural processes. LiDAR has changed the field dramatically. Remote sensing reveals thousands of bays that are invisible from the ground because they have been partially leveled by modern agriculture, drainage, forestry, and development. The ecological importance is also being reassessed. Carolina bays are biodiversity hotspots, supporting amphibians, plants, and birds that depend on seasonally flooded wetlands. Were they made by one force, by many forces, or by repeated Pleistocene rewriting of older scars? The next case shifts from a landscape carved by air and water to a structure that, if it is artificial, was carved by hands we cannot identify. Number 7. The Yonaguni Monument, Japan's drowned stone puzzle. In 1986, a local diver named Kihachiro Aratake was scouting for hammerhead shark dive sites off the southern coast of Yonaguni Island, the westernmost inhabited island of Japan, located near Taiwan. About 25 meters below the surface, he encountered a massive stone formation with sharp edges and what appeared to be terraces. The structure became known as the Yonaguni Monument. It is roughly 100 meters long, 60 meters wide, and 25 meters tall. What makes the monument visually striking is its geometry. It has flat plains, sharp edges, what look like steps, narrow channels, and several apparently right-angled surfaces. Underwater, with sunlight filtering down through blue water, the formation strongly resembles a stepped pyramid, a ceremonial platform, or a partially ruined stone structure. The temptation to see architecture is immediate. 2 scientists shaped the public debate. Masaki Kimura, a marine geologist at the University of the Ryukyu, has argued for decades that the monument shows clear signs of human modification, possibly a partially natural feature that was reshaped by people during a period of lower sea level. Robert Choke, a geologist at Boston University, examined the site and concluded that the features are entirely consistent with natural processes acting on the local sandstone and mudstone bedrock. The geology is the key to the argument. The bedrock at Yonaguni belongs to a sedimentary formation that fractures along parallel bedding planes and along nearly vertical joint sets. When you combine horizontal bedding with vertical jointing, you produce blocks that look rectilinear. Add seismic activity, because the region sits in one of the most earthquake-prone zones on Earth, and you get repeated shaking that can cleanly detach those blocks. Add strong currents, which Yonaguni has, and you get erosion that polishes faces and removes rubble. The result is natural stonework that looks engineered. A useful comparison is on land. Step-like sandstone formations exist on Yonaguni Island itself, exposed above sea level, and they show similar rectilinear patterns. This weakens the claim that the underwater forms must be artificial. The mainstream theory is that the Yonaguni Monument is a natural geologic formation shaped by bedding planes, joints, currents, and erosion. The historical theory allows that, during the last glacial maximum about 20,000 years ago, sea levels in this region were roughly 120 meters lower, exposing the formation to the air. Humans living along the coast at that time could plausibly have used or lightly modified it. The fringe theory, popular in some documentaries, is that the monument is a submerged remnant of a lost Ice Age coastal civilization, comparable in concept to the legend of Atlantis. The missing evidence is the deciding factor. There are no tools at the site. There are no ceramics. There are no inscriptions. There are no recognizable walls. There is no datable occupation layer. There is no diagnostic artifact of any kind. Exposure above sea level does not, on its own, prove construction. Yonaguni is one of the cleanest case studies in the concept of geofacts, which are natural objects mistaken for artifacts. Is this a drowned monument, or is the human brain seeing architecture in broken stone? The final case in our investigation flips the problem. The objects are unquestionably artificial. The meaning is what we have lost. Number 8. The Costa Rica stone spheres. The silent geometry of the Diquís. In the Diquís Delta of southern Costa Rica, scattered across river valleys and the southern Pacific lowlands, there are hundreds of carved stone spheres. Unlike most of the cases we have visited so far, these are not from the Paleolithic and they are not particularly ancient by global standards. The bulk of them are associated with chiefdom-level societies that flourished between approximately 500 and 1500 Common Era. UNESCO inscribed 4 major sites onto the World Heritage List in 2014. Those sites are Finca 6, Batambal, El Silencio, and Grijalba 2. The size range of the listed spheres goes from about 0.7 meters in diameter to roughly 2.57 meters. The largest examples are commonly reported in the range of 15 to 16 tons. The materials vary. Most of the famous large spheres are gabbro, which is a coarse-grained igneous rock. Others are made of granodiorite, limestone, or sandstone. The manufacturing logistics are part of the puzzle. There is no metal toolkit involved. Researchers, including John Hoops at the University of Kansas and the late Costa Rican archaeologist Iphigenia Quintanilla, have studied the production sequence. The likely process involves selecting boulders from rivers and quarries in the Talamanca foothills, transporting them sometimes tens of kilometers, and then shaping them through hammering with harder stones, pecking the surface in tight patterns, grinding away high points, and final polishing with abrasives like sand and water. High points were repeatedly identified and corrected, creating the impressive sphericity over weeks or months of labor. A note on the popular claim that the spheres are perfect to a fraction of a millimeter. That is exaggerated. They are impressively spherical given the technology, and the best examples deviate from a true sphere by only a small percentage of their diameter, but they are not machined precision objects. Original context is what was lost. At sites like Finca 6, some spheres remained in their original linear and geometric arrangements, often associated with mounded earthworks, paved areas, elite residential platforms, plaza entrances, and burial zones. Many other spheres did not survive in place. During the late 19th and early 20th centuries, banana plantation work by the United Fruit Company and others moved hundreds of spheres. Some were rolled aside, some were used as decorations on plantation lawns, some were dynamited because of persistent local rumors that they contained gold. The mainstream theory is that the spheres functioned as elite status markers, political symbols, and territorial displays. Their placement near elite residences and ceremonial centers fits this interpretation. The historical theory supported by the surviving in situ arrangements at Finca 6 is that the spheres structured movement and ritual within ceremonial spaces, marking pathways and key positions in chiefly architecture. The fringe theory, which is harder to test now, proposes that the original sphere arrangements encoded astronomical alignments, regional maps, or cosmological geometry. Because so many spheres were moved before they were systematically recorded, that idea is extremely difficult to evaluate. The Dikis spheres are a clean example of how a complex society can leave behind hundreds of monumental objects without leaving the instructions. There is no surviving writing system from the makers. Oral traditions about the spheres exist in the region, but they have been heavily reshaped by colonial contact and later folklore. The makers spoke Chibchan-related languages, but the specific cultural context for the spheres is gone. Were the spheres maps, status markers, ritual anchors, political architecture, or all of these at once? Each of these 8 cases leaves us standing in front of evidence that exists but does not speak for itself. That fact is not a coincidence. It is the structural condition of prehistory. Across the Ghost Hominin, the Cerutti Mastodon site, the Tarim Basin mummies, Libyan desert glass, the Acheulean Stasis, the Carolina bays, the Yonaguni Monument, and the Dikis spheres, one shared pattern emerges. Each case has evidence, but the evidence is incomplete, displaced, altered, or indirect. The Ghost Hominin is the DNA-only case with no fossil, artifact, or landscape. Cerutti is the taphonomy case, where bones and stones exist but intention is disputed. The Tarim mummies are the multi-proxy case, where bodies, textiles, diet, and DNA all exist but point in different directions. Libyan desert glass is the mineral physics case, where the material is real but the source event is hidden. The Acheulean is the behavioral case, where millions of tools exist but cognition does not fossilize. The Carolina bays are the geomorphology case, where landforms exist but formation may be multi-stage. Yonaguni is the geofact case, where the eye sees architecture but geology can mimic design. The Dikis spheres are the context loss case, where artifacts exist but original arrangements were destroyed. 2 technical concepts unite these problems. The first is equifinality, which is the principle that very different processes can produce similar-looking results. A spiral fracture can come from a hammerstone or from an elephant stepping on a bone. A rectilinear underwater block can come from a quarry chisel or from a joint in sandstone. The second is the difference between absence of evidence and evidence of absence. A missing fossil, missing crater, or missing inscription does not prove that nothing existed. It proves only that we have not yet recovered or recognized it. Dating in all of these cases becomes the spine of the controversy. Cerutti, at 130,700 plus or minus 9,400 years, is not just a number. It attacks the entire migration timeline of the Americas. Uranium series dating works because uranium absorbed into bone slowly decays into thorium, and the ratio gives an age estimate, although it depends on assumptions about how the bone interacted with groundwater. Radiocarbon dating, which is what most people imagine when they hear archaeological dating, only works back to about 50,000 years, which is why Cerutti required a different method. Argon-argon dating and stratigraphic analysis date Libyan desert glass to about 29 million years. Magnetostratigraphy and volcanic ash layers anchor the Acheulean to 1.75 million years and beyond. Optically stimulated luminescence dates the formation of Carolina Bay rims. Each method has assumptions. Each method has a margin of error. Precision is not the same as accuracy. A date can look exact and still be wrong if the underlying assumptions are off. The three theory lanes used throughout this investigation are not gimmicks. They reflect how working scientists actually think. The mainstream theory is the explanation most compatible with current evidence and standard methods. The archaeological or historical theory is a cautious middle ground that allows for human agency, lost context, or unusual regional complexity. The fringe or speculative theory is dramatic, possible to imagine, but weakly supported by direct evidence. Geneticists, geologists, archaeologists, taphonomists, and geomorphologists disagree for technical reasons, not for entertainment. The job of a careful investigation is to give weak ideas a fair hearing while pointing out the evidence each one fails to provide. How does knowledge get lost in the first place? Tropical forests dissolve bone, desert sand buries craters, construction sites scrape away fragile sediments, looters dynamite spheres, banana plantations roll monuments off their original positions, currents and earthquakes break apart underwater contexts, languages die, oral histories fragment. Even when objects survive, the relationships between them, which is where meaning lives, are usually the first thing destroyed. Archaeology overrepresents what does not rot. It underrepresents what was woven, painted, spoken, sung, and remembered. What do these horrors say about the human story as a whole? The Ghost Hominin challenges the idea of a clean human family tree. The branches were tangled. The Cerutti site, if accepted, challenges the timeline of human presence in the Americas. The Tarim mummies challenge the assumption that culture always follows genetic ancestry. Libyan desert glass shows that human history is built on a planet periodically struck by cosmic violence on timescales we struggle to picture. The Acheulean Stasis challenges the assumption that intelligence and rapid innovation always travel together. The Carolina Bays show that landscapes can record processes longer than human memory. Yonaguni shows the danger of confusing geometry with intention. The decay spheres show that complex societies can leave masterpieces without leaving the explanations. None of this requires magic. Ghost DNA follows inheritance, mutation, recombination, and population structure. Cerutti depends on fracture mechanics, sediment history, and tool use inference. The Tarim mummies depend on aridity, salt, and the chemistry of preservation. Libyan desert glass depends on heat, pressure, silica, and impact physics. The Acheulean depends on stone fracture, learning, repetition, and survival value. The Carolina Bays depend on wind, water, sediment, and climate. Yonaguni depends on bedding planes, joints, earthquakes, and erosion. The decay spheres depend on stone, labor, and lost social meaning. The most disturbing mysteries are usually natural laws carried to extremes by deep time. Innovation, across these cases, takes wildly different forms. A hand axe, refined and repeated for 1,000,000 years. A felted hat in a Bronze Age desert grave. A polished gabbro sphere weighing 15 tons. A fragment of glass set into a pharaoh's pectoral. A genetic sequence carried forward by a population whose bones we cannot find. Some of these innovations were practical, some were symbolic, some were not even human. Libyan desert glass is, in a sense, an innovation of the solar system itself, an object created by physics that humans later found and made meaningful. The past does not disappear evenly. Some signals last for hundreds of millions of years, others disappear in a single rainy season. The Earth keeps evidence, but it rarely keeps instructions. Every new method, ancient DNA sequencing, LIDAR, uranium series dating, microresidue analysis, computed tomography, and experimental archaeology, opens closed histories, and creates new questions in the same motion. The mysteries shrink as the methods sharpen, but they rarely vanish completely. Some of them, like the Ghost Hominin, may be solved within the next decade by a single well-preserved skull. Others, like the meaning of the Dikis may never be recovered because the people who knew the answer stopped speaking centuries before anyone thought to ask. What survives is not always what mattered most. A ceremonial sphere outlasts the ceremony. A genetic fragment outlasts the body that carried it. A piece of melted desert outlasts the catastrophe that created it. A hand axe outlasts the hand that shaped it. A mummified textile outlasts the language that named its colors. An underwater rectangle outlasts the certainty about whether anyone ever stood on it. So the final question is not whether prehistory is mysterious. It is whether we are willing to live with the mysteries on their own terms, holding evidence and uncertainty in the same hand, and resisting both the urge to invent answers and the urge to dismiss the questions. How much of prehistory is gone, and how much of it is still hiding in plain sight, waiting for the next method, the next excavation, the next genome, or the next storm to expose what we have walked past for thousands of years?